Hello, today I am going to share with you an alternative method to solve instrument output signal by using the graphical method. In my previous video, I have shown you how to derive both direct linear equation as well as reverse linear equation for instrumentation and control. But in today's video, I will use a alternative method, which is a graphical method, to do the same thing. Okay, let me draw a simple picture so that it will be easier for me to illustrate further. Okay, let me draw a line. Okay, let's say I have a pressure transmitter that installed in the field, and this pressure transmitter will measure the process pressure inside the pipeline. Okay, and this pressure transmitter has been configured as reverse acting transmitter. Okay, so reverse acting is different from direct acting. In my previous video, I have explained the difference between these two things. Okay, so let me explain again what is reverse acting. Okay, for example, you this pressure transmitter that measure the process pressure, and the process pressure range is 3 to 15 psi. Okay, since the pressure transmitter has been configured as reverse acting transmitter, so the output signal will be 20 to 4 milliamp instead of 4 to 20 milliamp. Okay, this LRV value, or the low range value or minimum value 3 psi, will correspond to 20 milliamp, while the URV, or upper range value or maximum value, of 15 psi will correspond to 4 milliamp. Okay, so if you want to represent the range in this graphical method, we can write in such a way. For LRV, or low range value or minimum value, the process range here is 3 psi, and the maximum value, or URV, upper range value, is 15 psi. Okay, as for the output signal, since this is a reverse acting transmitter, the minimum value that corresponds to 3 psi for the milliampere is 20 milliampere instead of 4 milliampere. As for the 15 psi, it will correspond to 4 milliamp instead of 20 milliamp. If it is a direct acting pressure transmitter or any transmitter, this URV will correspond to 4 milliamp. This URV will be corresponded to 20 milliamp. Because it is a reverse acting, the reverse thing will happen. That means the LRV corresponds to 20 milliamp, the URV value will correspond to 4 milliamp. Let's say this pressure transmitter that measure the process pressure, and it reads the pressure reading of about maybe 12.7 psi. So what will be the corresponding milliampere that will be generated by the pressure transmitter and sent to the PLC? Okay, so we can put the 12.7 psi here, and then we will need to find what is the corresponding milliamp output signal that will be sent to the PLC. So in order to find this milliamp signal, is very easy. So what you need to do is you need to take this URV value minus this 3 psi LRV value proportional to this value minus this value, and then this value minus this LRV value proportional to this milliamps value minus this 20 milliamp. So we can write in such a way: 15 psi, okay, 15 psi minus 3 psi is proportional to 4 milliamp minus 20 milliamp. 4 milliamp minus 20 milliamp. And then this 12.7 psi minus 3 psi, 12.7 psi minus 3 psi proportional to milliamp value minus 20 milliamp. So, okay, milliamp value minus 20 milliamp. Okay, then we can rewrite this in such a way: this divided by this value equal to this value divided by this value. Okay, that means 15 minus 3 psi divided by 12.7 minus 3 psi equal to 4 minus 20 milliamp divided by question mark, sorry, minus 20 milliamp. And then we write the equation. It will be 12.7 minus 3 divided by 15 minus 3 multiplied by 4 minus 20, and then the whole thing, sorry, then the whole thing plus 20 milliampere. So what is the corresponding milliampere? Let me calculate. 7.07 milliampere. Okay, that's it. Thank you.